So for those of you who are about to take Chemistry 111, General Chemistry 1, the first part of the chemistry sequence, maybe you've had chemistry in high school, maybe you have not, maybe you wish you had not. All of that is irrelevant. So we're going to be starting Chapter 1 in the OpenStax textbook. I'll put that information in this video's description. The beginning of chemistry requires us to quantify matter, and to do that we need to do some calculations. Now, rather than giving you just an algebra review of x plus y and whatever, I've decided to work through a problem to give you an example of how you're going to apply your mathematical skills. Without a doubt, one of the most important things you need to do is get yourself a good scientific calculator. Now, it doesn't need to be an expensive scientific calculator. It needs to be good. I've got a little Casio, and I'll put the description of this. It's like less than 10 bucks at Walmart. It's not very fancy, but it does everything you need for General Chemistry 1 and 2. Regardless of what type of scientific calculator you have, you need to know how to use it. I've had students in the past, many students in the past, that have a very wonderful calculator, can do all kinds of things, but then they try and put an exponent into it, 1.3 times 10 to the 7th, and the numerical answer they get is wrong. And it's not because they don't know what the math, it's because what they don't know is what the sequence of keys that you have to put into your calculator. In other words, each calculator can have its own computing language. So you could do it on paper, but if you don't understand how to do it with your calculator, you're going to get the wrong answer. So many times this is something that would be very frustrating to my students, that they know what they were doing, and yet the answer would be numerically wrong. And it's because they didn't understand how their calculator functioned. That's something you need to, again, read the instruction book or use YouTube as a resource to find out about your calculator. As we go forward, I'm going to take my calculator, put it to the side, because I'm going to solve this problem, but I'm not going to pick up my calculator. Now, this particular problem, if you've had these kind of things in your math classes, that's what's known as a word problem. Pipe leaks water with a rate of 0.72 milliliters per second. Calculate the volume of water in liters lost after 37.4 hours. Okay? This can look very daunting, but it's actually a pretty easy problem to solve. Before we can solve it, there are a few things we need to know, and either there'll be an expectation that you know certain unit conversions. Other ones would be given to you, or you can look up. The metric system, we have milliliter to liter. The metric system is something that is going to be covered in this course, and there is an expectation that you'll know how to do metric unit conversions, and I'll get to that when the time comes. But English unit conversions, imperial units, in this case time, we've got seconds, we've got hours. Those particular conversions, you have to know them, or you have to be able to look them up. So what I'm going to do off to the side is I'm going to say 60 seconds is 1 minute, 60 minutes is 1 hour. You can write out the word minute or hour respectively, or seconds, but it's not necessary. So we'll cover unit conversions and symbols and abbreviations going forward. Now, to solve this problem, and we're gonna cover this in a large detail with many examples going forward, but I want you to just see this to be able to dive in and start working these kind of problems even before classes start. We're going to use a technique called dimensional analysis, or factor label. This is by far one of the most important problem-solving methods, powerful problem-solving methods, that we cover in chemistry and just in science in general. I learned how to do this in general chemistry in high school. my junior year. I actually failed the first exam because I didn't understand it, and then once I got it, I was off to the races. So this is something that once you get it, you'll be fine, but initially it can be very frustrating. Okay? So how do we use dimensional analysis to solve a problem? Okay, so we read this problem. A pipe is leaking, it's got a rate of 0.72. Calculate the volume of water, liters, after 37.4 hours. So with dimensional analysis, I'm going to draw a line, and after it has an equal sign. Above the line, we're going to be multiplying units. Below the line, we'll divide through. And then, of course, we have equal. We actually start backwards with dimensional analysis. What is the unit of our answer going to be? Okay? Now, again, this is where the logic of how we solve a problem comes into play. The math classes that you've taken typically only have you x equals such and such, and then you do some rearranging, and then you find x is 7.444. Fantastic. But it's just a number. There's no physical unit associated with it. In this particular problem, we're looking for liters of water. Okay? That's a physical unit of measure. So we put liter. If we want to be more precise, we can actually write liters of water. But in this case, liter is perfectly fine. So that's where we're going to end. Okay? How do we start? Now, the rate that we're looking at might seem like the logical place to start, but this rate, you can think of it as a constant in this particular problem. That's our pipe dripping, and no matter how long we wait, it's going to be dripping at that rate. What we're looking for is what is the unique piece of information we have to start the problem. Well, in this case, calculate the volume of water in liters lost after 37.4 hours. Okay? So the 37.4 is the unique piece of information to start. In some problems, you might start with the wrong, quote unquote, the wrong conversion factor and be fine. Where you run into trouble is if you start in the wrong place, you might end up having your problem inverted. In other words, we might need to divide by this number instead of multiply. And if you start with it on top in the numerator, well, everything's going to seem backwards. In other words, it's not going to work. So if you find yourself working a problem and you get to a dead end, what you should do is go right back to the beginning and say, did I start with the correct unit of measure? So in this case, we're going to start with 37.4 hours. So I'll use the abbreviation HR for hours. And I draw this line. Now, in some textbooks, they use parentheses or other symbols. The line is simply to delimit each unit that we're placing in here. We're going to multiply everything that's going to be on the top, and then we're going to divide through by everything that's on the bottom. So the thing with dimensional analysis, and I didn't mention this at the beginning, it's simply multiplication and division. But what we're doing is we're keeping track of the units of measure, and that's the secret. Because if you notice, I don't have my calculator in my hands, it's over there. I'm going to solve this problem using units of measure, and then when I get to liter, which is the end, then I'm going to pick up my calculator and then do the math, do the algebra, multiplying and dividing. So the thing about dimensional analysis is once you get comfortable solving a problem based on units of measure, it doesn't matter what the problem is, whether you're talking about time and volume, whether you're talking about mass, whether you're talking about energy, or a combination of all of them. And that's going to be something that's critical in this course, that you'll have problems where you have a mass and then the answer needs to be in units of energy. Well, with enough conversion factors, you'll be able to get there. Okay? So learning this technique of dimensional analysis is absolutely critical. Hour is a unit of time. Okay, we're trying to get to volume. Well, we do have a relationship between time and volume. It's our rate of leak, right? The milliliters per second. But I can't use it yet. Why can't I use it? Well, the unit of time is hour, not seconds. Okay? So now what I have to do is I have to convert hours to seconds. Yes, you could pick up your cell phone and ask Google or ChatGPT or something like that, what is the conversion between seconds and hours, but you won't learn anything doing that, okay? So you want to do it systematically, and I'll show you what I mean by that right now. Over here, well, we know 60 seconds is 1 minute, 60 minutes is 1 hour. So what I'm going to do is I'm going to say, well, 1 hour is 60 minutes. Okay. Now, here is the absolute fundamental basis of dimensional analysis. I have the unit of hour, and I'm dividing by the unit of hour, so they cancel. How can I do that? Well, off to the side, if I have 2x, and it's divided by 3x, right? That gives me 2/3. X divided by x cancels out. It equals 1, right? In dimensional analysis, you treat the unit of measure exactly the way you would treat x or any other variable. We can't stick with hours because, again, we're trying to get to liters, we're trying to get to volume, but we can't use our rate of the leak because it's in seconds. Hours divided by hours, so now they cancel. Now we're in the unit of minutes. Well, again, we're trying to get to seconds, so what do? Well, we go 1 minute is 60 seconds. Okay. Again, drawing the line just to give myself demarcation. Again, you could put parentheses here and put the little x that you're multiplying, doesn't matter. Minutes cancel. Notice that the units are canceling, and we still, of course, have the numerical values. So from an algebra point of view, this is going to be 37.4 times 60 times 60 divided by 1 divided by 1. By the way, it's understood that there's a 1 here. You don't have to write it out explicitly. Well, look what we've done. We canceled hours, we canceled minutes, we have the unit of seconds. My rate of my leak is in units of seconds. Now, one thing I didn't mention, milliliters per second. What does that second to the minus 1 mean? Here. So if I have second to the minus 1, it's 1 over second. Actually, let me make that x, so keep it very generic. So a negative exponent means that we divide through. In the sciences, we use exponents. Seconds to the minus 1, seconds to the second, squared, and so forth. And we also use negative exponents, which means we're dividing through. So this means it's milliliters divided by seconds. And that's incredibly important because what do we have to do? We have to cancel seconds, and then we have to have units of volume, milliliters. Now, obviously, milliliters is not liters, but we're getting there, all right? So how do I use this? Well, milliliters per second, it's a different color, we're going to have 0.72 milliliters per second. Actually, you can put the 1 in there or not, it doesn't matter, right? So milliliters per second. Look what happens to the unit of measure for second. it cancels. Okay? Here's something that's very important in dimensional analysis. If I took 0.72 and divided it, I would have milliliters down here and seconds up there. The units wouldn't cancel. That's the red flag. That tells you, wait a minute, I need to stop and reevaluate this. Okay? Again, hours cancel, we have minutes. Minutes cancel, we have seconds. Second cancels, now we have milliliters. Milliliter is a unit of volume. We're trying to get to liters. We will cover this in class. The metric system is a very, very, very useful unit of measure. In fact, it's what's used in science because we simply go by powers of 10. And I'm not going to take the time to define this. So 1 liter is 1,000 milliliters. We will cover the metric system from kilo to milli and then a few other measurements as well. Why the metric system is so important is that, or so powerful, every unit change is a factor of 10. In the English system, you're all over the map. You know, 1 minute is 60 seconds, 1 hour is 60 minutes. 24 hours is a day, right? In other words, it's not consistently 60 or 24, 365, I think, in a quarter days is a year. It's got no rhyme or reason. In other words, whereas with the metric system, it's base 10. So now with this given, 1 liter is 1,000 milliliters. Well, how do we use that? Okay. 1,000 milliliters, we have to divide by 1,000 milliliters, gives me a liter. And again, you can put a 1 in front of it. The reason I'm not doing that is because 1x, right, is just x, okay? But it's not wrong if you do that. The most important thing, okay, so milliliters divided by milliliters. The units cancel. And after all of this, look where we are. We have liter as our unit. That's what we want. Specifically, it's liters of water. If you wanted to, you could write H2O or you could write the word water in here. In this case, I'm not going to be that picky for this. But what does this mean? Well, the only unit that's left is liter. That's the unit we want. We're done. All we need to do now is the math. Okay? Before I pick up my calculator, I'm going to take 37.4, times it by 60, times it by 60, times it by 0.72, and then divide it by 1,000. That will give me a number, and that's what goes here in front of liter, and you're done. Okay? So let me do this. I don't actually know the numerical answer. Times 60 times. Okay. And this gives me, I'm going to write it the way my calculator has written it, 96.9408 liters. Okay? That's what my calculator is telling me, and that is numerically correct. However, again, this is where we're going to differ from your math class. In calculations that deal with physical units, we don't get an infinite amount of accuracy. In other words, we don't get an infinite number of places in our calculator. We do physical measurements. So for example, someone measured the rate of the pipe leaking in milliliters per second. So they had a stopwatch and then something to measure the volume, and they have what are known as 2 significant figures. These definitions, I should mention, these are actually counting numbers. They have an infinite number of significant figures. This 37.4 hours, that has 3 significant figures. In dimensional analysis, when you're multiplying and dividing, the smallest number of significant figures limits what your answer can have. So we have 2 significant figures, or sig figs. So that means I need to round this to 2 sig figs. So my final answer will be 97 liters. Okay? You don't get extra credit for putting more digits because technically that's wrong. because you can only measure to a certain level of accuracy. And that's something we're going to be covering in this course. I highly recommend you read through chapters 1, 2, into 3 of your OpenStax textbook, or at least skim them, and that'll give you some of the framework of the kind of problems we're going to be covering early on. Dimensional analysis, if you've seen it before, fantastic. You can shake off some of the rust and you'll be ready to go. If you've never seen it before, do not despair. You'll be able to pick this up. As I said, I learned this my junior year in high school, and I learned it after I failed the first exam on dimensional analysis because I didn't get it. And then once I got it, I literally have never had any issues with it through my entire career. One last thing I want to talk about for this particular problem, okay? 1, 2, 3, 4 unit conversions, and we're done, okay? You're going to have problems where you might have 2 unit conversions, or you might have 7. It doesn't matter. Once you understand how to do it, it's just a matter of putting the numbers and units on the page, canceling it, and then getting to your final answer, with your units and then eventually your calculator. So once you get it, it's going to be fine. But if you, like I said, if you haven't seen it before, this can be very daunting. What dimensional analysis is replacing is the mathematical technique of ratio proportion. You can get the answer using ratio proportion. I'm not going to cover that simply because that's incredibly tedious. So you want to learn dimensional analysis because that gets you to the answer in the shortest amount of time.